How's everyone doing today? Well, 19 years ago, when Steve Jobs took the stage at Macworld right here in Boston, coming back from Pixar and saying, you know what, it's time for us at Apple to innovate like there's never been innovation before. So I was trying to create, at least in my own mind, some innovation to try to at least cover myself up with what Steve Jobs was able to do for Apple. The same way we can inspire ourselves what precision medicine is all about. He actually showed several slides at that 19 years ago Macworld. The first one was Apple has become irrelevant. Apple can't execute anything. Apple's culture is anarchy and can't manage it. He said there's a problem, but it's real easy to look at symptoms as opposed to the actual problem. This is what happened to Apple the previous 3 years. They were in rapid decline in their revenues. This absolutely wasn't the problem, this was the symptom. Similar to the way we in healthcare like to treat symptoms, clearly it's easy to look at this and want to treat it, but you can't do much with declining revenues. He said to himself the new beginnings would be a board of directors, focus on relevance, invest in core assets, meaningful partnerships, and new product paradigms. And he did something that was unprecedented. He reached out and did a major deal with Microsoft that day. Bill Gates got on the... Probably 6 years later, the iPhone was launched. And the innovation has been incredible over that period until his death, where you look at the iPods, the mouse, the iMac, the iPhones, Apple TV, and then the iPad, and then the MacBook. It's really, in our era, probably the most unprecedented level of innovation that you can ever imagine. And what's really quite interesting, if you look around the world right now, there's a level of innovation occurring in just about every field out there. And it's the digital revolution that's enabled this incredible level, whether it be driverless cars, whether it be passenger drones, whether it be artificial intelligence, ground funding. There are so many different directions the digital revolution has taken us. And if you just look at market capitalization of companies, really for about a 15-year period, you might find one or two per year getting to $1 billion valuation. But if you look what's happened in the last 18 months, it's just incredible the level of innovation that's occurring across all digital platforms and every field. Even folks like Facebook originally took like 7 years to get to the $50 billion valuation club. But then Uber comes along and Uber does it in 3.5 short years. Again, it's another testament to the speed in which this innovation is transforming the world. Some of you might have heard of this woman, Elizabeth Holmes. And you may be wondering why I'm wearing black, given what's going on in the industry right now. Apparently Jennifer Lawrence is going to play a new movie playing Elizabeth Holmes. It's going to be called Bad Blood. That's the truth, by the way. The reality in this is that science should precede evolution in our field. And so to just commemorate that, I want to just do one thing to Steve Jobs here, and that is just to put on my laboratory coat to be a testament that everything we do in this healthcare industry really does need to start with science first. And so I say this because I think we're getting a bad image based on some of the things that have occurred in the last 6 to 9 months. But the reality is that if you truly put science first, there's a way to transform this industry. And this whole conference, Precision Health, is an attempt to bring in the top minds in the world to try to evolve the science with a lot of publications and fact-based, and let the evolution of the overall digital revolution play its role on us. So we have a profound opportunity, and we do want to say science first. And so the overall goal of Precision Health is to bring innovation towards asymptomatic medicine before symptoms occur, that's personalized, but most importantly, accessible. We look at 4 major criteria when we were setting up PPH. Number 1 was leadership, big thinkers and influencers, science first, focused on the big 3. which is cardiology, oncology, and neurology, with inflammation being the one that's across all three of those fields. Meaningful collaborations, and then let's bring the digital paradigm into our landscape. There is an urgency. Just one of our employees' granddaughters at 23 years old, a day after her birthday, just passed away from cancer, literally came on them so rapidly. But everywhere you look in this world, we all are touched in profound ways. And all of you that haven't been touched, at any moment you could be brought to your knees, and you could be in a situation where you yourself is trying to figure out what's the best care for yourself or for a family member. You have someone that you really care deeply for, and you really want to try to find a way to help them. But you don't know if you're getting the best care, and you don't know, and you're really somewhat helpless, and you're desperately trying to do everything you can to help them. The reality is that getting innovation to patients can take 10, 15 years, and we've got to figure out a way to bring it quicker, and a lot of goal of PPH is to achieve that. So we started with what we call some of the biggest minds and influencers. Most of these folks will be on panels today and speaking. 3 folks on this list will not be here today. Rudy Tanzi, the founder of the Huntington Genes from MGH Harvard. Krishna, who heads up Google Ventures, also an MD at Brigham and Women's Hospital. And Raju, who heads up personalized medicine. All very focused in helping us bring PPH to where it is. And it's really only been a couple months of really focused effort to try to pull this all together, which has been quite amazing. As we mentioned earlier, oncology, neurology, and cardiology, with the focus on inflammation being a lot of the biomarkers that really infuse each one of those categories. And so we'll spend a lot of time also on inflammation. When the total of 350 people, obviously in Cambridge on a Monday morning, is not the best time to start a meeting, but when the 350 folks are here today, this is the percent that signed up and where they sit. 35% cardiology, 30 neurology, 15 cardiology, I'm sorry, 35 oncology to start, and then 20% are focused just on inflammation markers. We have an amazing lineup of speakers, both at panel sessions as well as tracks and keynotes. This is what makes this meeting. There's going to be several game-changing announcements made today. When I said we're putting science first, you're going to see today that several of these researchers have actually had trouble sleeping over the last week, week and a half preparing for this, because for some of them it's one of the most monumental moments in their careers and many of our careers, and sometimes these studies take as long as 5 years to perfect. So I got to tell you, some of the announcements that you're going to see in the studies today are a lot of what makes me stay in this field and really go after it, as well as I know a lot of you are here for the same reasons. And these are the associations that those groups are, those speakers are with. It's a pretty formidable cast. We also have a combination of innovators that are in the room, coupled with patient advocates, providers, therapies, and investors, all together. We think it really does require somewhat of a village to move profoundly across these technologies. And patient advocacy is one of the more important things, because anytime you make a game-changing technology and you announce it, the entrenched profitability of whatever is there today has a lot at stake to maybe undermine what it is that gets announced. And so having patient advocates with a lot of science-based advocacy to understand what's real and what isn't, to help us in the courtroom of public judgment is critical. So patient advocacy is something that we feel very strongly about, and you're going to see them inspire you today as well, because some of them are going through their own personal trauma, and they're trying to help us see what it is to live with this and to further inspire us to do what we all do. Today we have 5% of our audience advocates, 20% are providers, 50% are with drug discovery therapies, and 10% are investors. These are our sponsors, and we really want to thank them for sponsoring this conference. It's a big piece of making this thing work, is having them involved. And this is a list of all the folks that have helped pull this together over the last couple months. It's a pretty long list, but it's an incredibly important list. These people literally, some of them have worked overnight several times to just pull this together and make it happen. And at the end of this list, you can see I have my wife, my daughter, and my son who have actually lived some incredible hours trying to keep this all going in our households and have played a pretty important role inspiring many parts of what we're doing. They're actually in the audience as well. So what you're seeing there is us trying to bring a parallel between the internet system and our vascular system. We've got about 5.5 quarts of blood that's a treasure trove of information, particularly if you have the right detection technology, digital detection technology, to look inside of it. 60 miles of vascular structures go through every part of our body, to every centimeter of our body. And that brings an opportunity to really be testing the health of all parts of our body if we can truly get in there with rocket science and test those fluids from the body. So this is a big piece of what we're trying to bring together, is the ability to see all that, but then to connect it with the internet and keep it enriched with a lot of patient information. You're going to see in a moment, we think that there's an opportunity to reduce cost as much as 40% in our healthcare system. We've all heard a lot about Obamacare. I'm sure we're going to hear a lot about it tonight as well in the debates. The reality is that we think there's a shift towards prevention and early detection that can transform the economics, and we're going to show some data on that. We also think access has become a huge issue in our company, in our country, as well as around the world, and there's evidence that we can live 8 more years productively and die in our sleep as opposed to very traumatic deaths if we apply some of these principles. So let me start with sick care and describing today's somewhat treating of symptoms in our healthcare system. This to me is one of the most profound slides because it, on the left side, shows average life expectancy. Across the bottom is the amount of expense. And it just amazes me how well Japan and France and certain countries have done living as much as 8 years longer than United States citizens, but doing it for 1/10 the expense per capita for their lifetime. How in the hell can they spend that small amount of money and get that level of productivity? So we wanted to study this and understand, why is the USA so far out on the right side? Are we over-treating? Are we putting way too much into this? There's a lot of questions, because what's interesting has our life expectancy has plateaued, and for the first time, children born today in the United States have a shorter life expectancy than their parents. And if you look around the world, which diseases are really going to be evolving radically, you're going to see cancer, diabetes, basically almost doubling. Neurodiseases, because of the elderly with Alzheimer's, really picking up. And asthma and allergies are actually going to be the 3rd leading cause of death. So there's a lot of things going on here that could be environmentally induced. And I want to just show something that's interesting is that while United States overall life expectancy is plateaued, we've got more 100-year-olds than any country in the world. And we're growing at that faster. So we've got almost 2 different groups. We've got a lot of very healthy people that have access, they understand how to exercise and eat right and do all the right things for their health with preventative cares and early detection. But then we have a lot that don't get access, and they're really bringing down significantly the averages. So look at this, we're actually 31 out of 100,000, and they're projecting that this will be 50 within the next 10 years. That's how rapidly that group is growing. The number of 75-year-olds plus in the United States is going to quadruple over the next 10 years, to give you a sense how rapidly we're doing. Now, heart disease and stroke we've done incredibly well with, and you might say, geez, if we've done that well with the mortality rates in those categories, why isn't life expectancy increasing? The interesting thing here is that we're dying younger from those diseases. Because of those that aren't getting access, they're actually dying at a younger age. And so we got to be careful of metrics as being misleading, because the overall, we're not pulling together and collectively moving the economics. So when you look at cancer in the United States, breast cancer is by far the most newest area of issue for women, and they die the most from lung. Breast is number 2. Men get the most prostate cancer, and they die the most from lung. So obviously there's differences, but important areas of focus as we look at cancer. Some of the other kind of socioeconomic factors that have occurred is that if you look how much more car we drive today than we did 30 years ago, consuming a lot more fuels, we actually are consuming 110% more calories than we did 50 years ago per day, which is just amazing how much more we're eating per day. And we look at our living arrangements, we got less people per house, but we've more than tripled and quadrupled the size of our homes. And when you consider the population explosion, and that humans really have only been on Earth for like 1.1 second of a full year, if you look at the Earth on a full calendar year, we've been here for like 0.1 second, and are taking our population in the last 30 years, we've more than doubled it, and we're going over 7 billion right now. So feeding this world and keeping it closed and sustained when we are living like this is really putting a lot of stress on the system. Interestingly, we've talked about France and Japan. Check out their sugar consumption versus United States, 37 and 22 versus 216. We're actually consuming 160 pounds of sugar per person in the United States. 160 pounds. This is like unbelievable economics when you consider the food industry and what it's doing for them, and we're going to show that in a moment. Energy, we're consuming more than double these countries, and obesity is running rampant. Actually, 2/3 of the United States is either obese or overweight, so the fact that we're showing obesity here is just a part of the story. And by the way, they're expecting this is going to go up by 50% based on current trends over the next 10 years in the United States. Now, what the hell's going on? We do know that obesity and overweight are a major component to cancer, and this has become much more understood in the prevention sciences. Obviously, tobacco's there as well. But just look at 1994. This shows the colors of the country on obesity and diabetes, and this is less than 14% most of these colors. In 10 short years, look what's happened to the United States in obesity and diabetes. And these are environmental factors that are just overwhelming our systems and just driving inflammation, which is what we're going to measure like never before, and we're going to get ahead of it this time. Food is an addiction, unfortunately. I actually was in the food industry for a little while, and I watched scientists calculate the bliss points with brain scans. They were looking for the bliss point when dopamine was being released to create the addiction, the ratio of salt, fat, and sugar. What was that perfect ratio to allow the stomach to get bigger and to create addictions? It's a real science, and healthy food, by the way, unfortunately, is not addicting. 70% of our intake in the United States caloric is from processed foods. So liking's one thing, wanting's one thing, but when you need it, that's when you really have the addiction. And this is a lot of our issue. 2/3 are either overweight or obese, quadrupling the cost just in the United States. It's a global epidemic, and luckily 60 Minutes and others have started to really provide insights on this. Interestingly, we subsidize big time sugarcane and corn in the United States. Those subsidies make that ingredient almost zero price for the food industry. They use it as buffers, and they use it to really reduce their costs. Not only that, we're feeding corn into most of the poultry, the cows, and even the salmon, thinking that that's helpful because of the food supply being at zero cost. What it's really doing, it's being done also with pesticides. Many growth hormones are being used throughout, which is a big piece of our breast cancer issue, and also obviously antibiotics. But when you do all of that, you're really overinflating the omega-6 overload and hormone imbalance. You're really stimulating inflammation and that insulin growth factor. So hey, this is like science that we really all should be teaching ourselves and understanding throughout our country. This is a big piece of what the income, and if you could fix this and really treat everyone in our country with access to what it is to change the diets, you really do have a chance of changing access. So there's a double whammy, and clearly these inflammation pathways are leading to those diseases that we've talked about earlier. Neurological disease has got some really profound statistics as well, and we're talking about that today. Alzheimer's is going to be at an epidemic level in our country. It actually kills more than breast cancer and prostate cancer combined, which is something that we hadn't really thought about. Alzheimer's is, I have an aunt that's 99. I was with her this past weekend, and she's starting to show some dementia. After 99 years, you'd think that that's okay, Aunt Helen, you can do this, but it's just so traumatic to watch it even at her age, and many people are suffering from this in their 40s and their 50s, and it's getting younger and younger. We've got to get to the essence of these environmental factors and what's driving into some of this. We're going to see some incredible news today. This is Dr. Bob Stearns, was on 60 Minutes. He's going to be in the second panel. We all know who this is. Those of us that are patriots, this is the moment to boo. Thank you. The reality is that he's trying. He just put $100 million towards concussions, and we've actually won, Quanterix has won the award twice for their ability to see concussions in blood. Pretty profound stuff, and you're going to see some breakthrough science in this area, both in concussions and CTE. I've been personally affected by this. Many of you probably have as well, but bicycling accidents for children are the leading cause of traumatic brain injury for children. There's so many categories of issue that's going on. Again, there's no science, there's no blood test for the brain. Banyan's here with us today. We've got new technologies. This is the new area. The heart was this way 50 years ago. You would present with chest pains, and slowly they started to get biomarkers to look in the blood to see the heart health. Same is going on with cancer. The brain, though, has never had the advances that we have an opportunity to do with a lot of this digital technology. So we're going to talk a lot more about this. But the reality is that these people are leading very challenged lives, and it creates trauma for the entire family. This is a major epidemic that we've got to get ahead of, and we're now talking about it, and we're going to see 2 NFL players here today further describing for you their own personal situation. One of them's got a couple Super Bowl rings, one of them's both of them are local broadcasters. Again, there's a movement of people that want to help and get into this from all angles, and it's up to us. We're the talented people. This is the most talented group in the history of my career that I've seen assembled in this room as well as with this panel. We've got to find ways to start this discussion and collaborate. That's an environmental factor. Head injury is an environmental factor for many diseases. Just like smoking might be an environmental factor for lung cancer and heart disease, concussions could be a very clean environmental factor for neurodegenerative diseases. So that's why we have it in this section. I also want to point out that drugs themselves, unfortunately, only work about half the time. And in some categories, they work about 25% of the time. And what's really challenging here is that it may be one of the biggest environmental factors we have. All you got to do is watch the commercials on TV, and sometimes you wonder if there's Saturday Night Live commercials with all the trauma that they say that it could create as side effects. You wonder if the benefit is even worth some of it. So getting better efficacy for toxicity is a primary driver for the industry, and they're making major headway on looking at on-target efficacy and off-target toxicity. These immune therapies, we're going to hear a lot about them today, some of the leaders in the field with great response levels with very minimal side effects. So now let's talk a little bit about disruptive technologies that go after this. Next-gen pathology, it's been around for a while, very key. The light microscope took a long time to bring to market. Digital imaging took about 10 years. PCR took about 5 years. The NGS revolution has been incredible. Dr. Walt is with us today, founder of Illumina. He'll be speaking in a moment. There's no doubt that there's been an incredible insurgency of the next-gen sequencing capability throughout the world. My view is that it's incredibly important, but there's other things that should complement it, and that's a lot of what we're going to talk about today. The whole concept of moving from analog to digital inside of the biomarker world, I think is key, and we think is key for seeing disease before symptoms, detecting abnormalities that were previously undetectable, and measure change from their healthy baseline. This is just a little video clip that shows the way these high ultra-sensitive digital biomarker technologies work. You can see that there's a bead with an antibody that grabs onto the protein, puts a light on it, and then ultimately these beads go into these wells, and that digitizes the experiment. So it's almost like running 500,000 experiments on one sample is what you're capable to do with these technologies. And by the way, they can be done for DNA, RNA, they can be done for microRNA, mRNA, as well as proteins, and we're now even moving into episomes and some other areas of molecular structures that we're showing great promise with this concept of digitizing the biomarker. I did want to also point out that, while there's one copy of a gene that might lead to 10 copies of an RNA, it could lead to as many as 1,000 proteins. And so in many ways, proteins are more prevalent in the body for a given copy of the DNA. Interestingly, the protein cascade can be very relevant as well, as we have watched the impact of all these factors of epigenetics, all these factors of environmental affecting protein structures. We've seen many identical twin studies where one twin grows up to get cancer, the other twin grows up to get heart disease, but yet they started out with very similar host genes. But their environmental, the way they live their lives, all the factors that we talked about can affect those protein cascades. So maybe the protein can be even more relevant in many respects, as well as more prevalent. So if you're looking for detection technology, you want to go where there's prevalence and relevance. Going back to Steve Jobs, we're applying a lot of those principles and what we're talking about for digital biomarker analysis. So what is it about a disease? There's about 325 proteins today that are approved for diagnostic use. About 171 of them are IVD proteins as opposed to laboratory developed tests. And when you look at the detection limit today, when we think we have 0, those are all really telling you about disease primarily. When the protein level elevates in concentration, today's technologies can come down and read it and tell you you've got a disease. So once you've got the symptoms, it can tell you that. The key here is moving that detection limit up and getting down to a whole new 0 and allowing these 4,000 proteins that couldn't be detected before to now be detected, and look for these correlations for early stages of diseases so you can get to them much sooner. And this is the profound movement that we're feeling across all these different molecular structures can play a role. And we're seeing evidence of 1,000 times more sensitivity when you moved into the digital world of biomarker analysis. 1,000 times is really changing the game because most of the inflammation markers can't be viewed when you're healthy at today's level of sensitivity. But when you go 1,000 times down, you can see inflammation markers when you're healthy and when you're diseased. And that, we think, is the revolution of seeing that annually during your physicals. These are just some examples. This slide here, all the yellow is where these markers are naturally in the body, and the green is what today's technologies can do. And here's where some of the newer digital technologies can read sensitivities well below where these markers are in the blood. And there's some markers that aren't even be able to put on this. The greens are way up here, but the technology now has advanced very rapidly in areas of troponin and many of the cancer markers to see way down underneath when you're still healthy. So today, the PET scan world for cancer, it's a big market, 30 billion, some estimate 60 billion just for cancer. Now, there's this whole new field emerging called liquid biopsy market. They're projecting, JP Morgan, Goldman Sachs, they're in this meeting today. They've been projecting somewhere around 20 to 40 billion of opportunity to look at all these markers in blood and see things very early and see if treatments are progressing as they were intending to progress. So you take the blood out, you separate it, you isolate the critical molecules, and then you use a lot of different technologies, including digital biomarker analysis, to assess what's occurring. And we think that this will allow much higher levels of accuracy, non-invasiveness, less expensive, and allow you to get to it earlier. Versus today, we know there's major issues, which we're going to show in a moment with a lot of today's imaging, but it's still a very important piece of our company and our country. 28 billion is the overall market, we think, for life science research, diagnostic, and these health screens when you start to look at what might be possible with this liquid biopsy market. So there's a huge opportunity to do a big transformation, almost an Apple level of transformation right here in healthcare. By the way, Apple's valuation today is like 650 billion. If you multiply that by 5, you have what we spend each year in healthcare in the United States. So you get a sense of just how much value creation has occurred in Apple, and it's a level of innovation that it's approximating the way we're spending in our healthcare system today. How do we take these technologies and really move them aggressively into healthcare where we know we need it and we know there's evidence? So let me just take a walk down oncology for a second. We've got one of the leaders in the field, Dr. Bob Weinberg's here today, who wrote the 10 Hallmarks of Cancer. I am just honored to have him with us today. He'll be on the panel. We're going to obviously have him give us an update on this, but this area of using the immune system to fight cancers has been one of the most profound areas of advancement in the last 50 years in cancer management. I just love this guy. 92 years old, stage 4 melanoma. They gave him 3 months to live. That was over 9 months ago. There's no evidence in his most recent scans of any cancer. Just incredible stories. Sorry about, for those of you that aren't at Merck, but that's a Merck drug. There's a lot of other great drugs too, from BMS and others. But here's a lot of these inflammation markers that I've been telling you about. You can't see them with today's technologies, but you can read them today with these digital technologies, both at healthy levels and at disease levels. And these are really allowing you to look at suppression levels, inflammation levels, surveillance, and tolerance to these drugs. Another great drug that's occurred in the last 5 years, Zelbaroff, that's for the BRAF mutation. People with stage 4 melanoma completely getting cleaned up. So you can't dispute the progress that's occurring in many of the drug industries with 80% response rates for anyone that has that BRAF mutation. The Angela Jolie effect is something I want to just comment on. The BRCA gene, if you have it with a mutation, you're 1 and 2 are ultimately going to get cancer by age 70. On average, though, 12% are going to get cancer of the breast by age 70, women that is. Men are getting it now at a much greater rate with all these hormones in our food supply, but not nearly at the rate that women are getting it. So key here is that a lot of people are taking surgical proactive action if they're in these categories. But I also wanted to show this other slide, part of the slide here, where when you do have breast cancer, they subset you, and if you're HR positive, hormone receptor positive, there are some great drugs. If you're triple negative, that's where the challenge is. About 13% of women are in this category, and we really have a lot of trials that are honing in on the triple negatives, and it's just so exciting to see, and you're going to hear more about this today. So in any given year, 1,000 women, 100 of them are going to get basically a positive read in the mammogram, 10%. Over a 7-year period, 50% of women are going to have a false positive that's going to lead to a very anxious 3 weeks. And it's just horrible to watch and listen to what happens. And luckily, I've got some insights into pathology and knowing how this all works. And it's just unbearable to think how this test works. But in the end, 5 people out of the 100 will ultimately be diagnosed with the cancer. But there's a lot of anxiety and process that has to go through the core biopsies and even resections. And what's really coming out is that obesity, exercise, pregnancy, really getting after these hormones and pesticides we showed earlier, minimizing alcohol and sugar consumption. These are all ways that this spreading epidemic can be prevented. I also wanted to show one more example. These were 33 men that had prostate cancer. They had a radical prostatectomy. PSA is supposed to be 0 once they've had it. They were all told it was 0, but then New York University and Johns Hopkins used some of this digital biomarker technology and found out that actually a portion of them were sitting over here. And as it ends up, if you had less than 10 picograms per ml, the cancer didn't return in a retrospective trial for 5+ years. If you're anywhere above 10, this group here, the cancer came back within 1 year. So this is an example of where these biomarkers, even though everyone thought they were 0, it changes the game. And we have to get on with this. It's time. It's time. It's our burden, our duty to bring these technologies to bear. We cannot sit on this any longer. We've got to get moving. I've got different urologists and oncologists that are pounding at me saying, people desperately need this. People read these publications and they call in, can we get our PSA tested, post-radical prostate? That stuff isn't there yet. It's not commercially available. We got to get moving. That's what we're working on. Neurology. As we mentioned earlier, there's tests for every organ in the body except the brain. The brain gets traumatized. The markers get released into the cerebral spinal fluid. A small portion, typically about 1/50th, find their way into the blood. And this is at such low concentrations. That's where digital biomarker analysis allows us to see these. There's a lot of leaders from around the world that are focused on this. Julian Edelman, as we all know, had a pretty big concussion a couple years ago. It's a Super Bowl game. There's a lot of questions being asked. Is there a concussion? How severe is it? Jessica Gill will be publishing a neurology paper coming up where they actually measured tau, and based on a reading from tau just 6 hours after the concussion, they can predict which players can return to play in less than 10 days versus going to have a more post-concussive syndrome. These are the kinds of studies that are being done and with very great scientists to be presented at this meeting. Also, there's a lot of discovery work going on for these different drugs. You've heard all about Biogen's recent announcements with their new stratified cohort. Incredible news. We're going to have the chief medical officer from It's actually not the CMO, but a designate. Jesse will be actually on our panel today from Biogen. We also have a Biogen presenter, Danielle, on our track. A lot of progress. And in cardiology, where we have made a lot of advances, it's primarily around prevention. And as we know, all food's not the same. Mediterranean diet, they've actually done some pretty profound studies, 7,000 cohort group over the last 5 years, and they found that 30% less likely to have suffer a cardiac vascular disease event after 4 years if you eat nuts, oils in the Mediterranean diet. So there's real evidence now becoming more fact-based. And these are the sciences that I think really allow us to change healthcare expenditures in the country. And troponin, we keep measuring it. We're going to see Peter on one of our panels today, one of the leaders in troponin, but early on you could only measure a heart attack if it was a major heart attack with troponin. And then as sensitivity levels came down, you could start to see mild heart attacks. And now you can see heart attacks maybe as much as a month before the event, because you're getting into the troponin levels and release. Still a lot of work to be done on those studies, but there's beginning evidence suggesting that you can see these long before symptoms present. Wearable devices is another big category. How do you merge the wearable devices with the biomarkers into some kind of an internet-based device? These are the ways that we have to keep advancing these technologies. And again, if we don't get together and push this forward, it'll take 10, 15 years. So many companies will go bankrupt that have the breakthrough technology if we don't team up with investors to teach them how this can change the world. Every aspect of what we're doing in this conference is all about making sure we collectively push these technologies forward. So in closing, I'd like to say that detection and treatment have been a big focus. A lot of people call it precision medicine. Precision health, we want to add prevention because we think that's a science that's just ripe for a breakthrough with this ability to see in the blood or in the vascular system or in samples from the body very early, preventative opportunities. And how are your lifestyle each year, how's it affecting? If you have children playing soccer and they're having their annual test and they're looking at their neuromarkers, are they starting to have concussions from all the headers that they're doing or the types of activities that they're doing? It's a big area of concern. I know a lot of soccer moms that call and say, should I allow my children to play soccer? I'm very concerned based on the newest science. The science, there's a lot of studies coming out on soccer. We know a lot of former professional soccer players that have quit the game because of concussions and have seen some of the trauma of CTE. We also know that there's a lot of other sports and a lot of other activities. There's 10 million CAT scans per year for head trauma in emergency rooms now, and only 8% of those 10 million yield positive results on brain lesions. So 92% of those CAT scans, based on current science and evidence, aren't providing any value at all, but they are probably doing an environmental factor of inducing radiation into the body. So all of these things are things we want to look at when we talk about prevention. And I'm going to close with this last slide here. This kid here, Tommy, he played football with my son. Senior year, he gets diagnosed with a brain tumor. Literally 9 months later, he passes away. My next door neighbor, 12-year-old, healthy as can be, no cancer anywhere in the family. She gets a brain tumor. She dies like 9 months later, Allie. We've all been afflicted and seen the trauma, but there's things that we can be doing in each of these categories of oncology, neurology, and cardiology by looking at these inflammation markers and really getting at this and bringing the science to bear. And I'll just close by, my daughter actually is having someone do some work in their condo, and he himself says he's had 7 concussions in his life. He's a builder, and he moved here from overseas, and he basically says he experiences a lot of the CTE, but he knows a lot of the athletes. And he saw Junior Seau one time pull up in Boston and get out of his car, and he just looked completely confused. And he was just like trying to figure out where he was just in Boston after playing with the Patriots. And this guy felt so bad, and he was so turmoiled, and it was so agonizing for Junior himself to not be able to figure it out. Just like my Aunt Helen at 99, when she starts to get dementia, it's the torment where she sees people not talking to her, and it torments her.
And so these people are living with such agony and such distress, and we need to feel some of that ourselves to really propel ourselves and inspire ourselves forward. This guy, Junior Seau, 9 months later took his own life, and he did it by shooting himself in his chest to preserve his brain, because he felt so bad and knew that it was his brain that needed further evidence for the work that was being done. And I bring it out just to say to you, we have a chance to really revolutionize the way these healthcare systems, these healthy systems can work. It's up to us to make this thing happen. I am so driven by this. It's the reason I even came out of retirement to get back involved with these digital biomarkers. I just think that they've got such an opportunity to change the way medicine and health is practiced, and I really thank you guys for being here today. I encourage you to really get into the panels, interact with people, try to collaborate, leave here with inspiration to really drive what you can do from where you sit to the next level. Each of you can do something significant. I would challenge you to figure out what is it that you can do to further this cause of bringing this stuff to help our patients sooner and quicker and start to really revolutionize the way health is practiced. Thank you very much.